Good day, everyone. We will now solve problems pertaining on exact differential equations. So here are our examples that we will solve later on. Okay, let's start with our first example. So our first example is 4y plus 2t minus 5 derivative of t plus 6y plus 40 minus 1 derivative of y is equal to 0. So before we solve any exact differential equation, we will first try to check if the following differential equation is exact. So that is by using the partial derivative. So we assign our m as a function of t and y would be equal to 4y plus 2t minus 5. Okay, then we get the partial derivative of m with respect to, since this is derivative of t, that is with respect to y. So that would be derivative of 4y with respect to y plus derivative of 2t with respect to y minus derivative of 5 with respect to y. So this would be 0 because the other variable is termed as a constant. So our partial derivative would be 4. Next, for n, as a function of t and y, that would be equal to 6y plus 40 minus 1. So we will derive n with respect to t this time. That would be partial derivative of 6y with respect to t plus partial derivative of 40 with respect to t minus partial derivative of 1 with respect to t. So again, the other constant is a variable. Okay? Our constant here is y. So it means your derivative would be equal to 4. So they have the same partial derivative. So it means this differential equation is exact. So since this differential equation is exact, so we will now solve, okay, our differential equation, function of x and y. This is our solution. That would be integral of our m as a function of t and y dt plus our function of q of y. Okay? So we integrate, that is the integral of 4y plus 2t minus 5. This would be dt plus a function of y. So again, since we are integrating with respect to t, your y here is constant. So since y is constant, we can factor out 4y integral of dt plus 2 integral of t dt minus 5 integral of dt plus a function of y. So that would be 4yt plus 2t squared over 2 minus 5t plus a function of y. And that would be 4yt plus t squared minus 5t plus a function of y. Next, we will solve for the solution of n. Okay? Function of, that must not be a function of x and y, rather t and y. Okay? So function of t and y would be equal to the integral of n as a function of t and y dy plus r of t. Okay? So that would be the integral of 6y plus 40 minus 1 dy plus a function of t equals. So in this time, we integrate with respect to y, so it means t is constant. So if t is constant, it means we could factor out your t later on. Plus 40 integral of dy minus integral of dy plus a function of t. Okay? So that would be equals 6 y squared over 2 plus, okay, that would be 40y minus y plus a function of t. Simplify further, that would be 3y squared plus 4ty minus y plus a function of t. So again, for our final answer, we will just have, okay, we'll just pick one. So let's just pick this answer, that is 4ty. Okay, plus t squared. That is minus 5t plus a function of y. So let's check on the other solution. What are terms containing y only? So you have this one and this one. So it means we will add 3y squared minus y equals c. That is our final answer. Okay, next. Next, number 2, that would be x plus y squared plus 2xy plus x squared minus 1. Derivative of y is equal to 0. Again, we will check if this differential equation is exact. So we'll assign our m as a function of x and y. That would be x plus y squared. So what would be the derivative of m with respect to y? That would be m, which is x plus y squared with respect to y. So again, since this is x plus y squared, we could actually have this one as a normal derivative. That would be 2, okay, x plus y raised to 2 minus 1, then multiplied to the derivative of the inside function. So that would be 2x plus y multiplied to derivative of x with respect to y plus a derivative of y with respect to y. So this would be 0 because x is constant, and this would be 1. And our final answer for the partial derivative, that is 2x plus 2y. Okay. Next. For n, that would be xy equals to xy plus x squared minus 1. Okay. So we will derive rather n with respect to x. That would be 2xy with respect to x plus, that would be x squared with respect to x minus 1 with respect to x. So since y is a constant, so we could factor out y here. Then we have derivative of 2x plus, so your derivative of x squared, that would be 2x. This would be 0. And the final answer would be 2y plus 2x. So it means the differential equation is exact. Okay, since it is exact, we can now solve for our solution value x, y. That would be equal to the integral of m as a function of x and y dx plus a function of y. That would be integral of x plus y squared dx plus a function of y. Again, since we are integrating with respect to x, y is constant. So to make this easier, actually we could distribute first the squared function. So that would be x squared plus 2xy plus y squared dx plus function of y. So in this time, we could now separate the terms. Since y is constant, that would be x squared dx plus 2y integral of x dx plus y squared integral of dx plus a function of y. So that would be x cubed over 3 plus 2y multiplied to x squared over 2 plus y squared x plus a function of y. And simpler form, that would be x cubed over 3 plus x squared y plus xy squared plus function of y. Okay, next for our n, that would be integral of n as a function of x and y dy plus a function of x. So our n here, that is 2xy plus x squared minus 1 dy plus a function of x. So since we are integrating with respect to y, x is constant. So since x is constant, we could factor it out from our integral. That would be 2x integral of y dy plus x squared integral of dy minus integral of dy plus r of x. Okay? So that would be 2x multiplied to y squared over 2 plus x squared y minus y plus function of x. So that would be xy squared plus x squared y minus y plus a function of x. So we will now pick what would be our solution. So let's just pick this one. You copy xy squared plus x squared y minus y plus. So what terms in this solution only contains the variable x? So this one. So it means our answer would be x cubed over 3 equals C. That is our final answer. Okay. Next. Our next example would be sine y minus y sine x dx plus cosine of x plus x cosine y minus y dy is equal to 0. So again, let's check if the following functions are exact. That would be sine y minus y sine x. So we will derive our function m with respect to y. That would be derivative of sine y with respect to y minus, so since x is a constant, so we can factor out x. That would be cosine y minus sine x. Next, for our n, that would be as a function of x and y equals cosine of x plus x cosine of y minus y. Okay? Derivative of n with respect to x. that would be derivative of cosine x with respect to x. So since y is constant, we could factor out cosine y minus derivative of y with respect to y. Okay? So that would be derivative of cosine x, that is negative sine x, plus cosine y minus 0. And eventually that would be cosine y minus sine x. So it means this differential equation is exact. Okay, so since it is exact, we can now solve for our solution. That would be function of x and y equals integral of m as a function of x and y dx plus a function of y. So our m is sine y minus y sine x dx plus q of y. So since we are integrating with respect to x, y is constant. So since y is constant, we can factor out your y here minus y integral of sine x dx plus a function of y. So that would be sine y multiplied to x minus y. Okay, integral of sine x, that would be negative cosine x plus a function of y. So our answer for f of x sa m, that would be x sine y plus y cosine x plus q of y. Okay, next. For n of x and y, that would be integral of n of x and y dy plus r of x. So integrate your cosine x plus x cosine y minus y dy plus r of x. So since we are integrating with respect to y, x is constant. So since x is constant, okay, we could factor out x here. That would be integral of dy plus factor out x. That would be integral of cosine y dy minus integral of y dy plus r of x. So that would be y cosine x plus integral of cosine y, that is sine y x, sine y minus y squared over 2 plus r of x. And for our general solution, okay, you just copy this one, x sine y plus y cosine x, okay? Then we check what function of y only contains in this term, that is minus y squared over 2. So it means that is minus y squared over 2 equals c. That is our final answer. Next, we have example number 4. Okay. Again, let's check first if this differential equation is exact. We assign for our m as a function of x and y. That would be 2xy squared minus 3. So the partial derivative of m with respect to y, that would be partial derivative of 2xy squared with respect to y minus partial of 3 with respect to y. Okay, so since we are deriving with respect to y, your x is constant. Okay, this is 0. So that would be 2x multiplied to 2y. So that is 4xy. Next, for our n. that would be 2x squared plus 4. We derive our m with respect to x. Okay? So that would be 2x squared. So in derivative of 2x squared with respect to x plus derivative of 4 with respect to x. So derivative of 2x squared would be 4x plus 0. So this is 4x. So since the partial derivative is not equal, so this is not exact. Okay? See, next. We go to the last problem. That would be 1 plus ln of x plus y over x dx equals 1 minus ln of x dy. Okay, first, let us transpose our dy to the right side. So it means it will change its signs. And now we can assign for our mx as a function of y. So that would be 1 plus ln of x plus y over x. So derivative of m with respect to y, that would be derivative of 1 with respect to y plus, okay, constant ang ln of x, derivative of 1 again. So derivative of ln of x with respect to y plus, okay, constant. Our variable x is constant, so constant ang 1 over x multiplied to derivative of y with respect to y. That would be 0 plus 0 plus, okay, that would be 1 over x. So 1 over x. How about our n as a function of x and y? That would be 1. Or rather, ln of x minus 1. So derivative of n with respect to x, that would be derivative of ln of x with respect to x minus derivative of 1 with respect to x. So the derivative of ln function, that would be 1 over x minus 0. And eventually that would be 1 over x. So this differential equation is exact. And since this is exact, we can now solve for the function x, y. That would be equal to the integral of m as a function of x and y dx plus q of y. So what is our m? That would be 1 plus ln of x plus y over x dx plus a function of y. So since we are integrating with respect to x, y is constant. So since y is constant, we distribute. That would be integral of ln of x dx plus. Okay? So this time, since n is constant, or rather y is constant, so it means we can factor out your y. Okay? So factoring out y, we have y integral of dx over x plus q of y. Okay. So next, let's integrate. That would be x. The integral of ln of x would be x ln x minus x, diba? Using integration by parts. Okay? Plus y. Okay? Integral of dx over x would be ln of x plus q of y. So this would be x plus x ln of x minus x plus y ln of x plus q of y. So we can eliminate the x. That would be x ln of x plus y ln of x plus q of y. Okay, next, for our n, dy plus function of x. Okay, we just copy. That must be ln of x minus 1 because we have transposed it to the other side. So since we are integrating with respect to y, your x is constant. So since x is constant, that would be ln of x dy minus integral of dy plus a function of x. So that would be y ln of x minus y plus a function of x. And, okay, we'll now get our final answer from here. Okay, let's get it from here. That would be y ln of x minus y. And we check all the terms containing the variable x only. So we only have one, this one. So it means that would be plus x ln of x equals c. That would be our final